Hello and welcome to class P29, that's resistance welding process. And we're just going to have a few quick words about resistance welding electrodes and some of the options that are available to you. Basically, the electrodes for resistance welding fall into a couple of different categories. Now, there's many, but these are the two basic ones. Everybody's experimenting with different ways and different coatings on resistance welding apparatus and consumables, try to get them to last longer. But these are the basics. Basically, your copper-based alloys fall into Group A. Now, they have good, now because of copper being what it responds very well to cooling and it responds very well to electrical and thermal conductivity, and it's probably the most common. Group B get into something called the refractory metals, and they're not really as conductive as Group A, and they could be alloys of copper, yes, but they've added things to them to give them high melting points, extra compressive strengths under some of the extra forces we have to put some of the joints under. It's unfortunate, but sometimes the joints are a little bit restrictive, and we actually have to put a lot more force than we want to pull those joints together. When that happens, we know we have other tools in our toolbox that we can turn to try to get some life out of the production of this cell, and that is to go with the refractory metals. Typically, we start getting into copper and tungsten on those particular materials. So electrodes have these properties that they need to hold up to, and that is they need to conduct electricity very well, and they need to conduct heat very well. There's an internal cooling system, as was shown before. In the internal cooling system, water is circulated in the backside of the cap, but we need a very quick reaction between that water in the back and what's going on inside the cap. That also leads us to believe that we need to monitor and be in control of the water flow that's going through this gun. Never underestimate that situation where the water flow might be restricted. And because the first thing I do when I get to a place they say this particular machine's giving us trouble, the first thing I do is open it up, pull the caps out, and make sure all the tubes are proper. There's a tube in there that's cut off on an angle. It's very important that tube is the right length and goes into the cap the right distance. If it's too short or too long, it'll start causing problems, and you'll end up getting gas. You're getting steam inside that cap on the other side of it. When that happens, we are not giving it good efficient cooling. And our electrode can vastly affect the strength and the hardness of our weld, and that is by making good contact if it's very dirty. If we are using steppers, which is another course for another time, which actually boosts the heat a little bit to compensate for a poor electrode. That's one way it can do it. But most often people are turning to tip dressers now, and tip dressers are the way to go. You almost get a brand new contact tip every time they show up. But they have their challenges as well. And it's very important that whatever you're using doesn't alloy well with metals, the metals that are being welded. Sometimes some of these coppers, we're welding something that actually is more like copper and it will fuse itself to it forever. So if we end up in a situation like that, I might turn to the refractory metals right away just to make sure if I'm doing copper sheet, if we're working with our roofing people that work with sheeting for a roof, this is something we got to consider. And we're going to go to a refractory metal right from the get-go, or there's a special tape we can weld through to keep it from sticking. We talked about water flow already, and let's show this again. So when I pop this cap off, you should be able to see an angled tube sitting right there. Now this tube is cut at an angle to make sure that if it gets too close, it doesn't cause any turbulence. So what we're looking for here is a swirling of water right here to keep this cap cool, so we don't get a pile of steam. You might hear it knock sometimes after welding. If you ever start hearing any knocking in this area, you'll know you're getting steam locks in it. That is, it's getting so hot so fast, and the water flow could be inaccurate, flowing, and that is it's got some type of blockage, or the configuration is wrong. Something's wrong with the tube is missing, something like that, right? So the processed water, usually it's got to be under a certain amount of pressure. It's got to be under a certain amount of flow and control. We've already talked about the tubes being very important. And the issues with cooling will display, and this is very important, as parameter fluctuations. So you're thinking to yourself, this one's hot, this one's cold. What is going on here? It's almost like it's inconsistently shooting. And if you start to look at the power source, if you're starting to look at the power source like you're doing some strange things, I don't think you looked at the water close enough. Go ahead and make one last good look at the water and make sure you're not having any problem when it comes to flow. If you have to put in a temporary flow meter to find out, if it's fluctuating, and also be conscious of the pattern of the water. I've seen people set up water flow in a cell, almost daisy chain. So it's the actual water is going along through everything, and it's literally heating up as it goes through the entire process. You might have the water touching 3 or 4 caps on the way. That's not the way it's done. That's not the way it's done. We need to manifold things properly. We have to make sure that water goes to 1 cap and leaves. We don't want it going to multiple caps and starting to get hotter. This is another variable that we don't need. Resistance knows no bounds when it comes to control. If we get things hot, they will change. If we get things cold 5 minutes later, it'll be different. Just some different electrodes, electrode configurations. Nobody likes these eccentric ones, and nobody's very fond of these flat ones. The radius are the most popular, and they're probably the most popular because of so much zinc galvanizing we're seeing on parts these days. A round surface, where once it gets hot, it'll start to push the zinc out of the way to help us, as opposed to getting the zinc involved in what we're doing. And we certainly never want zinc to be introduced to a liquefied material, for sure. Okay, thank you very much for your attention on when it comes to the tips. Of course, I'm always available to discuss this further and see if you have any further questions. Thank you very much.